Hi students, in this chapter we will talk about the reflection of light. You see light reflected every day as you look at plane mirrors all around, isn't it? You see the reflection of your face in a mirror every day. That involves reflection of light. So we will talk in detail about reflection of light in this chapter. We learn about the laws of reflection, we learn about the fact that light travels in straight lines, and many other interesting things. Let's proceed. There are so many interesting phenomena related to light in our own daily life. In fact, light, even governs the fact that we see different objects around us. We see different objects when, light from a light source gets reflected from those objects and it reaches us. Understood? So, for example, the light from the sun, it strikes this donkey here and it gets reflected from the donkey back to our eye, and that is when we see the donkey. You see the chair around you, because light from the sun or light from the tube light or light from the light bulb gets reflected from the chair and then it comes back to your eye. So we see objects when light gets reflected from them. Understood? So of course, not only is light very important for us, the process of reflection is also very important for us, and that is what we are going to touch on in this chapter, the reflection of light. Understood? An interesting thing related to the reflection of light is the fact that light travels in a straight line. You must have observed that if you're in a relatively dark room and someone shines a torch at you, a shadow will be cast behind you, isn't it? You must have even observed the shadows of trees, the shadows of buildings. Take a look at this animal here. As you can see, as soon as light is shined upon this animal, a sharp shadow is cast. The fact that shadows exist proves that light travels in straight lines. Understood? After all, if light did not travel in straight lines and if it could curve around objects, in that case, it could curve around this animal and reach this portion here where the shadow is being cast, isn't it? However, that doesn't happen. Light does not bend. It travels in straight lines. In this chapter, we are going to assume that light always travels in straight lines. We'll also try to represent light, using straight lines called rays. Understood? Of course, in higher classes, you will learn about some other fascinating things about light too. In higher classes, you will learn that light does not always travel in straight lines. Light travels in straight lines, or light appears to travel in straight lines only when the objects which we are viewing are very, very large, compared to a certain property called the wavelength of light. Basically, if objects are very tiny, of the order of nanometers, in that case light does not cast shadows. Understood? So very tiny objects of the size of nanometers, which is 10 raised to minus 9 meters, that is 0.000 and 901 meters. When objects are of that size, they do not cast shadows. Light bends around them and it does not travel in straight lines. This is a phenomenon, however, that you will study later in class 11th and class 12th. Understood? This special phenomenon of light bending around very tiny objects is actually called diffraction. So you'll study about all this in later classes. For now, you must assume that light travels in straight lines. Let's get back to our discussion related to the reflection of light. Let me revise the laws of reflection which you must have learnt about in your previous classes. As you already know, there are two laws of reflection. These laws of reflection are valid whenever light strikes any surface and when it gets reflected back from it. I hope you understand the meaning of reflection. Reflection simply means that a light ray strikes a medium and then comes back in the same direction. That is what reflection is. The first law of reflection says that whenever a light ray strikes a reflecting surface and when it gets reflected, in that case the angle of incidence is equal to the angle of reflection. Here this yellow ray that's striking the reflecting surface first is the incident ray. It is the original light ray that is striking the reflecting surface. This light ray, after reflection from the reflecting surface, is the reflected ray. The angle of incidence is the angle between the normal at the point of contact of the incident ray and the reflecting surface and the incident ray. Understood? So this is the normal here, this orange dotted line here, that is perpendicular to the reflecting surface. This is the normal. The angle between the normal and the incident ray is called the angle of incidence. The angle between the reflected ray and the normal is called the angle of reflection. According to the first law of reflection, the angle of incidence is equal to the angle of reflection. Understood? So here you can see that the angle between the incident ray, this ray that's first striking the reflecting surface, and the normal to the surface is theta. You can also see that the angle between the normal and the reflected ray is also theta. So there you go. The angle of incidence is the angle of reflection. This law is true no matter what kind of reflecting surface we use. In this case, we can see that the reflecting surface is plane, isn't it? It's like a straight line here. But even if we use a curved reflecting surface or a spherical reflecting surface, the laws of reflection will always hold. Understood? So this is the first law of reflection. The second law of reflection says that the incident ray, the normal, and the reflected ray all lie in the same plane. What does that mean? This means that if there is an incident ray that is striking a mirror and it is getting reflected, forming the reflected ray, in that case, that incident ray, the original ray striking the mirror, the reflected ray, the ray that comes out after striking the mirror, and the normal, to the reflecting surface, the line that's perpendicular to the reflecting surface. All these three, normal, incident ray, and reflected ray, lie in the same plane. Understood? What do we mean by the same plane? The same plane means that if you take a piece of paper and you draw the incident ray and the reflected ray, then the normal will also be in the same plane. That is on the same piece of paper as the incident ray and the reflected ray. It won't be perpendicular to the piece of paper, or it won't be at an angle 30 degrees with the piece of paper. Understood? If you take a piece of paper, you can draw the incident ray, reflected ray, and the normal on the same piece of paper, because all of these three lie in the same plane. So this is the second law of reflection, and this is also valid, no matter what the reflecting surface is. So these are the two laws of reflection we had studied earlier and that we have now revised. We had also studied image formation by a plane mirror in previous classes. Let us again revise this image formation in this class. This vertical mirror you see on your screen, this grayish white one, is a plane mirror. This orange dotted line is the normal to the mirror. It is perpendicular to the mirror. Now let us take a green object, this object here, and place it in front of the plane mirror. Now let us try to find out where the image will be. In the case of a plane mirror, the image of this object will be formed at the same distance from the mirror as the object. The image will be formed behind the mirror. Understood? So in this case, the object is placed in front of the mirror on the right side and the image is formed on the left, behind the mirror. Understood? The distance between the mirror and the object is the same as the distance between the image and the mirror, that is d. In the case of a plane mirror, the size of the object is also the same as the size of the image. So whenever the image of an object is formed behind the mirror, in that case we generally say that the image is virtual. Why is that so? You see, if you take a mirror, and you look into the mirror, you will see that your image is inside the mirror, isn't it? But if you take a screen or if you take a piece of paper and hold it near the mirror, will you get an image on the screen? You won't, right? Because there is no real image. There is no image being formed in reality. The image is only being seen by your eye inside the mirror. Understood? Such an image which is not formed by real rays is called virtual. Understood? Real images are images which are formed when two or more rays intersect in real life. Understood? While virtual images are formed when our brain imagines that some rays are intersecting, though they are not actually intersecting. Understood? All these concepts might seem a bit complicated, but as we keep on studying, and proceed, with this chapter and the next chapter, you will clearly understand what a virtual image is and what a real image is. For now, you can simply understand that a virtual image is formed behind the mirror and it cannot be seen on a screen. When the image is not inverted, that is when the image is in the same direction along the y-axis as the object, then we say that the image is erect. When you look into your reflection in a plane mirror, you see an erect image. If you are standing up, you see the image also standing up, isn't it? Sometimes this doesn't happen in the case of curved mirrors, and then we see inverted images. But in the case of a plane mirror, the image is also erect. The object distance is the distance between the object and the mirror, and the image distance is the distance between the image and the mirror. In the case of a plane mirror, both these distances are the same. Another interesting fact in the case of a plane mirror is that the image is laterally inverted. What does laterally inverted mean? Laterally inverted means that the left side becomes the right side of the image and the right side becomes the left side of the image. You must have observed this, in your daily life. If you take some text and if you put it in front of the mirror, you will see that the text inside the mirror, reads in a weird way. Every letter gets inverted inside the mirror from left to right and right to left, isn't it? This change in an image, that is its left side becoming its right side and its right side becoming the left side, in the case of an image of a plane mirror, is called lateral inversion. Understood? So the image in a plane mirror is laterally inverted. So these are the characteristics of an image formed by a plane mirror when you place an object in front of it. In this class, the extra thing we will study is curved mirrors. Understood? Now what are curved mirrors? Simple. Mirrors which are not straight. A spoon is a simple example of a curved mirror. If you look at yourself using the open end of a spoon, the end of a spoon that is curved outwards, in that case, what do you observe? You will observe that the spoon forms an inverted image of you. In fact, you can try experimenting by bringing the spoon near yourself and taking it away from yourself with the larger curved outward sides facing you. When the spoon is very near you, you will see a very large, image of yours in the spoon, and that image will be straight. As you take the spoon away from you, you will see that the size of the image keeps on decreasing, and you will also see that your image becomes inverted inside the spoon. As you take the spoon very much away from you, you will see that the size of the image decreases considerably, and the image still stays inverted. So all this weird stuff happens in the case of curved mirrors. Similarly, if you turn the spoon around so that the portion that bulges towards you faces you, in that case what do you see? You will see that the image is always erect, but it is always of a very small size. So very interesting things happen in the case of curved mirrors. Exactly what kind of image will be formed when an object is placed at a certain distance from a curved mirror? That is what we will now learn. The special kind of curved mirrors that we will talk about in this chapter and the next are spherical mirrors. Spherical mirrors are mirrors that are formed when you break a sphere, and use the broken part as a mirror. So here you can see a mirror sphere. This sphere has a mirror on all sides. Now if I break this sphere or I cut out a portion of this sphere, then each portion will function as a mirror, isn't it? If I cut this sphere in such a way that the bulging portion has the reflecting surface, that is this portion, the silvery grey portion you see on your screen, has the reflecting surface, and the inward portion, the green portion here, does not reflect, in that case the mirror is called a convex mirror. So basically, if I cut a portion of the sphere in such a way that the outward bulging portion has the reflecting surface, I get a convex mirror. If on the other hand, I cut the spherical mirror in such a way that the inward, this portion of the mirror, has the reflecting surface, the inward non-bulging portion has the reflecting surface, in that case, I get a concave mirror. Understood? So these are two special kinds of mirrors that are formed when we cut a sphere into different parts. Understood? And these are the types of mirrors we are going to study in the next chapter: concave mirror and convex mirror. Understood? A concave mirror bulges inwards while a convex mirror bulges outwards. And before we study more about concave and convex mirrors, let's solve a problem. Which of the following statements are true? A. The laws of reflection are valid for both spherical and plane mirrors. Spherical mirrors obey the first law of reflection but not the second. A spoon can serve as both a convex and concave mirror. A concave mirror has the reflecting surface curved inwards. So well, which of these options is correct? Let's look at each option and see whether it's correct or not. The first option says the laws of reflection are valid for both spherical and plane mirrors. This option is definitely true. After all, the laws of reflection are always valid, no matter what kind of mirror we use. Option B is wrong, because spherical mirrors obey both the laws of reflection, not just the first. What about option C? Option C is correct. A spoon can serve both as a convex and a concave mirror. If you look at the spoon, the inward curving end of the spoon facing you, you get a concave mirror. If you look at the spoon with the bulging end of the spoon facing you, you get a convex mirror. There you go. A concave mirror has the reflecting surface bulging outwards. Convex mirror has the reflecting surface bulging outwards, isn't it? In fact, if a mirror bulges outwards, it's a convex mirror. If a mirror, has the inside curving portion reflecting, then it's a concave mirror. So this option is also wrong. So there you go. You have understood the basic concepts related to concave mirrors, convex mirrors and spherical mirrors. Let's now proceed to the next chapter and understand exactly how images are formed in the case of concave and convex mirrors.